Today we're going to look at a Multimorphic PD-16 coil driver board. Several modern games use this type of driver board, including Spooky Pinball and American Pinball, as well as homebrew games. This video I'm going to talk about how to test the N-channel MOSFET transistors, as well as how to replace them. Usually your pinball machine should have diagnostics that tell you which coil might not be working in your game, which would translate to the Q number that's screen printed on the board itself. So if you can do a coil test with your game and determine which one is not working, that will point you to which Q number might be shorted. If, for example, you have a whole line of coils not working, it's likely attributed to the fuse that's blown. So you need to check that. Depending on the manufacturer, they might specify a different fuse rating, but these fuses are 5x20 millimeter slow blow, and depending on what it's driving, it could be a 4 amp up to a 6 amp fuse. So check with what your manual says and replace it as necessary. Now let's take a look at the transistor itself and how it functions. To test these, you'll need to set your multimeter to diode test, and MOSFETs are a little bit tricky to test compared to some other transistors. The first thing we'll do is check the diode function of the transistor, which is right here is the Zener diode. And this tests just like a normal diode, and how you do this is, see how it has a banded side of the diode and a not banded side of the diode, and that goes right in line with the diagram here. So you take your black lead and you put it on the banded side, and your red lead and you put it on the non-banded side, and you should get numbers on your multimeter. If you flip those, red on the banded, black on the non-banded, you won't get anything. You'll get a null reading. So that is showing that it's good. Basically, a diode works as a one-way valve for current. So in the same case here, you got the source, or gate, drain, and source of the transistor, and so you'll put your red lead on the source, black lead on the drain, and you should get numbers. And if you flip them, you should get a null reading. Now let's test the gate feature of this transistor. How this works is when voltage is applied to the gate, this will close the switch and provide a path from gate to drain. To test this, you take the black lead on the source, red lead on the drain, and you'll get a 0 reading. But when you take your red probe, this always has some voltage going to it. When you put a small amount of voltage to the gate, this will now activate the transistor. Now you take that same lead and go back to the drain, and it will show it's open. So now it created a path for voltage to flow. and that is testing good. If you want that to go back, all you have to do is you short out the pins with your finger, and then you do the same test again, and it'll give you a 0 reading. So that shows that the gate is working. Now let's take a look at how to test transistors in circuit on the PD-16 coil driver board. You can flip it over so the metal tabs are facing you on the table, and it'll look just like the diagram on the paper here. So we'll first check the diode function, placing the red lead on the rightmost pin, the source, and the black lead on the drain, middle pin, and you should get numbers on your display. If you flip those around, black lead on the source, red lead on the drain, you should get a null reading. Now let's take a look at the gate function of the transistor by placing the black lead on the source, red lead on the drain, and you should get a null reading. But when you apply voltage to the gate, the leftmost pin, and then go back to the drain, you'll get continuity. That is showing that that's good. Now take your finger and you can ground out all the pins, and then when you go back and do black lead on the source, red lead on the drain, you'll get a null reading. That's showing that this transistor is good. Now you can move your way up and test the diodes on each one of the transistors. So you can see that I'm getting good diode readings on each one of these, showing me numbers, and then I'll go back through and I'll flip the leads, testing all the diodes. So this should give me a null reading going all the way down on each one. Now, make sure you ground out all the pins with your fingers. Take your black lead on the rightmost pin, the source, red on the drain. Now go over to the gate, charge that, and then go back to the middle, and you should get continuity. And then you do that all the way up. Ground out your pins so there's no charge on the transistor. Now take the red lead and the black lead, left and right, and see here it should be a null reading, but you're getting some values here. But so that should charge up the transistor and close the gate. When I go back over, I should have continuity here, but I don't. So it doesn't necessarily mean that that's bad. What we're going to do is move up the way and test all of these the same way, and I'm getting consistency here. I keep moving up, and I'm still not getting continuity. But then when I get to this one that I've marked bad here, I have a short. And so what is going to happen is when I replace this transistor, all of these are going to function normally again. Now that I've found the bad transistor, the next step is replacing it. The easiest way to do this is to flip over the board to the component side and then take some flush cut, these are Heiko flush cut snips, and you want to cut the transistor off as close to the body as you can and give yourself some leads to work with. Just cut that off, and now you have some leads sticking out here that you can pluck these out. So the solder pads on these boards are not very robust, so you can easily damage them if you're not careful. Now you take some solder and you add it to the pins, and you want to push these down through the holes as far as you can. What we're going to do is we're going to pluck them out from the front side of the board. So do this for all 3 pins. Now that you have them pushed through the board, you can heat them up and pluck out each pin individually. Okay, now that those pins are removed, go back to the back side of the board again, add some fresh solder, now take your solder sucker and clean out the holes. Sometimes you don't always get it on the first try, so make sure you go back and add a little bit more solder. And then try again. There we go. There you can see the holes are cleaned out. Now take your new transistor, put it in the same way that the position of the other ones are going. Flip your board back over. And then solder in the new transistor. You want to heat up the leg first, and then you can make the solder draw in through the hole. You don't need to put too much heat on those solder pads. Like I said, they are a little sensitive. Now take your flush cut snips, snip off the leads. To make this look like a professional job, put a little bit of alcohol on the solder pads and scrub it with a toothbrush, and that will clean off any of the excess flux. Now let's test the function of the transistors now that that one has been replaced. First, we'll look at the diode function again with the red lead on the source, black lead on the drain. This is testing the diode function. You should get some numbers from that. You flip the leads around, black lead on the rightmost pin, red on the center pin, and you'll get a null reading. Now you test the gate, and black on the right pin, red lead on the gate to charge it up. Then you move over to the center pin and you should get continuity. That's showing that that is good. The one that we replaced was this second one, so black lead on the center, red on the right, you should get numbers. You flip those around, black on the right, red on the center, you should get null. Then you charge up the gate on the leftmost pin, then you go back to the center, and that should give you continuity. And you should have the same characteristic of all the transistors in that line. Now that you've checked all of your transistors are good, make sure that the fuses are the correct value for the game. Check with your manual to see what value this is supposed to be. So this one was blown, so I'll replace that before putting it in the game to test.